Hello. Welcome to my channel. In this video we are going to talk about parallel lines cut by a transversal and the theorems of parallel lines. First of all, I drop the Euclid's definition of parallel lines, produced by the Greek mathematician almost 2,500 years ago. Two parallel lines cut by a transversal form 8 angles. 4 form the intersection between the transversal and the first line, and 4 from the intersection between the transversal and the other one. The angle with the same colors in figure are called corresponding angles, because they are formed in the corresponding corners with the transversal. Furthermore, we define alternate interior angles, alternate exterior angles, and consecutive interior angles. The diagram on the right can help you identify these pairs of angles. If we have two parallel lines cut by a transversal, we get congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior angles, and supplementary consecutive interior angles. These statements will be proven in the next video, the Part 2. Meantime, we can see that in the figure above, we have the corresponding angles of the same color. If we want to use the same colors for each set of congruent angles, we notice from the equations below that two only colors are required. So we have two sets of 4 congruent angles. It is also true that if we have two generic lines cut by a transversal, and the corresponding angles are congruent, then the lines are parallel. This also applies to congruent alternate interior angles, congruent alternate exterior angles, and supplementary consecutive interior angles. So we have 4 different theorems to prove. We want to start proving this statement. If two lines are cut by a transversal, and the consecutive interior angles are supplementary angles, then the lines are parallel. We are going to use a proof by contradiction. Let's suppose that the two lines are not parallel, and therefore they meet in a point P. If we consider the purple triangle in figure, we notice that a prime is an exterior angle for the triangle. The exterior angle theorem assures us that the exterior angle is greater of each non-adjacent interior angle of the triangle. So we can state that a prime is greater than D. We also know that C and D are a linear pair of angles. When two lines meet in a single point, they form 4 angles, and each couple of adjacent angles formed in this way are called a linear pair of angles, and they are supplementary angles. But one of the hypotheses of the theorem assures us that even C and A prime are supplementary angles. So D and A prime should be equal in value. We have so obtained a contradiction, and the assumption that the two lines are not parallel must be discarded. Therefore we have proven that the lines are parallel. We have just proven that if two lines cut by a transversal form supplementary consecutive interior angles, the two lines are parallel, as we have seen before. The same is true for congruent corresponding angles, congruent alternate exterior angles, and congruent alternate interior angles. We are going to prove the latter case. We proceed quickly, since the proof is similar to the previous case. If we suppose that the two lines are not parallel, they should meet in a point P. We apply the exterior angle theorem to the purple triangle, and we obtain that A prime is greater than D. But we know from the hypothesis that A prime is equal to D. We have arrived at a contradiction. So the lines must be parallel. We speedily move to the case of congruent alternate exterior angles. We notice that C' and A' are supplementary angles, and so they are A' and B'. From this follows that B' and C' are equal in value. Knowing that B and C' are congruent, we come to the conclusion that even B and B' are congruent. But B is an exterior angle of the purple triangle, so it must be greater in value than each of the internal angles. We have again a contradiction. So the lines must be parallel. One statement is left to prove. That is the case when the corresponding angles are congruent. I'm sure that now you can prove it by yourself. It's very similar to the three cases that we have seen here. In this video, we have shown how to prove that two lines cut by a transversal are parallel. Starting from information about the angles, we haven't yet seen how to prove the reverse implication. So, in the following video, we will start from the hypothesis that the lines are parallel, and we'll prove the relationship between the angles. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.